Hello everyone, this is my experiment on using the homemade water bottle thermometers. The overall question for the activity is how can I keep a water bottle cool when I am outside on a hot day? Success would be determined by the students finding the optimum location and creating the best insulation method for their water bottle. These are the steps for the entire experiment, however, I will break them down in my personal example on the following slides. On the left are the two water bottle thermometers I made using black paint on one and white paint on the other. As you can see on the left, the water bottle painted black conducted most heat as the balloon is more full than the white. So that obviously tells us that the black water bottle attracts sunlight. On the right, you can see the goal of the water bottle would be to remain cool. I chose the black water bottle because even though it conducts the most heat, you can tell that sitting in a refrigerator overnight, it conducted no heat as the balloon is even sunken into the water bottle. After 15 minutes in 80-degree weather, and as you can see on the right, the one that was in full sun on pavement is in the bottom right corner of the screen, and clearly the balloon inflated fully, showing that this is the location that attracts the most heat, which we would not want to use for our water bottle. Overall, I would decide that the shaded grass and shaded concrete would be the two best locations. So how did I determine which one would be better? I went to the ones that of the same surface but in full sun, and the one in full sun in the grass had a little bit less inflation in the balloon than the one in full sun concrete, so I determined that the grass is a cooler location in general, and that's where the water bottle will be placed. So now I had to do some research. I would have students research different types of bottles, and they could do this online as well as different bottles that I would bring into them, such as the Tervis, a Yeti, even a hospital mug that insulates very well. And we would disassemble them or look at different websites and videos that disassembled these bottles for them to get an idea of how they wanted to construct their own. Many of these bottles are designed with layers, a layered approach to insulate, or with a vacuum seal. Since a homemade vacuum seal can be very challenging, I decided to use the layered approach. I first started with a paper towel layer to help keep the bottle insulated, and not allow heat through. I taped the paper towel down and then wrapped it in saran wrap to again seal in that insulation. I put a layer of tin foil around to help reflect the heat and trap in the cool water, and then put a layer of saran wrap between the aluminum foil and finally duct tape. I didn't want the duct tape and aluminum foil to trap heat, so I put the saran wrap in between and decided to use duct tape on top, as again it would reflect any heat and sunlight and hopefully help absorb the coolness inside of the other layers. I then placed it in the shaded grass, and after about an hour I tested the water, even by drinking it, and it tasted like it came out of my refrigerator. For students to compare the different water bottles that the variety of groups made, I would use ice cubes in the water bottle to determine whose bottle had least amount of melting of their ice cubes. So the engineering design process follows with finding the coolest location and determining how to keep a water bottle cool outside on a hot day. Students would explore by researching insulated bottles and cups and why they work. Then they would consider their design by the research and the use of findings and their own creativity for their own ideas. Then they would make their insulated water bottle with materials that were provided. They would test out their design in the coolest location that we had determined, and they would reflect on their outcome and find ways to improve their insulated bottle with various methods. So the STEM practices that this addressed was, in science, asking of questions. The question was, how can we keep a water bottle cool? Obviously, also in science, we were able to obtain, evaluate, and communicate the information. We could discuss our findings as a group orally, or we could use a graph to show which water bottles kept the water coolest. In engineering, they plan and carry out investigations by conducting and making their insulated water bottles, and they would analyze and interpret their data and suggest changes and other solutions. In technology, they learn how to use new technologies as they became available. And this can be seen as they use the internet and their research to look at how other people have used technology to make insulation to inspire their own ideas. And then finally, in math, they used appropriate tools strategically with the materials that they had to make their insulated bottles. And the resources that were used to conduct this experiment, other than those searched on websites, would be our class text of STEM Lesson Essentials, grades 3 to 8, Integrating Science, Technology, Engineering, and Mathematics by Vasquez, Snyder, and Kammer.